Hello all, very good morning. Thanks for joining the session. Let me share my screen in a moment. Yeah, I'm sharing my screen. Okay, so thanks for joining the session, Apache Kafka. So let's see now. Of course, by this time, we all definitely got to know what is Apache Kafka, right? So you are attending this Apache Kafka session, at least you came here for the demo meeting. You might have at least heard about this word, the fancy word called Apache Kafka nowadays, everywhere it is using. So what is this Apache Kafka actually? In real time, we have seen the issues in two cases. One is continuous streaming. One is continuous streaming. In Java, we have the toughest challenge in handling the continuous streaming. Of course, before Apache Kafka, I would like to say. So in order to streaming, we have to use the circuit programming. Earlier, in order to do the stream, first of all, what is streaming, sir? So what is streaming? So streaming meaning the data that will flow continuously from the one source to, from the one or more sources to one or more sources to one or more targets. One or more targets. The data will flow continuously from the one or more sources to one or more targets. Then that we call it as a continuous streaming. Continuous streaming. Of course, I'll take one example. With that example, we will see. So let me share one architecture with you. So usually, if we can see the microservices architecture, we have the various challenges with that microservices architecture, right? One of such challenges, yeah, we have the this is the microservices architecture. The one of the challenge for us to is addressing the asynchronous communication in microservices is what one of the challenge we have. What does it mean, sir? What does it mean is, if we can see this architecture diagram, category service, product service, order service, and payment service. So category service, product service needs to call this category service. So let me show some workspace, meaning some application. I'm just trying to make you to understand the so what is Apache Kafka and what its importance and where we will use it exactly. Am I audible, guys? Am I audible? Anyone of you? Can you please confirm, because someone is claiming that he is not able to hear me. Am I audible?
Yeah,
Yes,
we
audible.
are
Yes,
audible.
audible.
Okay. Thank you so much. Thank you so much for that. Yeah. Okay. Yeah. Thank you so much. Right. So let us see one use case. Of course, there were plenty of the use cases where we can use the Kafka. So first, we need to understand the clear difference between the Kafka and then RabbitMQ. Actually, what is Kafka? Where we will use?
Hello.
Yes, yes.
Sir, I think you are muted. We are not able to hear your voice.
No. I think problem is with you where others able to hear me. Seems to be your mic issue. Others able to hear me. Okay. Yeah. Okay. Fine. So I'm trying to explain you in real time how the situation will be. I think you are able to see my screen. You can see one source code snippet, isn't it? That is, which is in the, if you can see, Shopify Me product brand service. Let me open the Shopify Me product brand service. Yes. So this Shopify Me product brand service is one service. And there is another service called category service. So this is a microservice, Shopify Me product brand service. It is doing an outbound communication call to the, so there is a listener. So AMQP protocol we used here called RabbitMQ. And then this is listening to a queue. So let me take an advantage to draw some diagram here just to understood why we need the Kafka, why we need to go for Kafka. I would like to make you to understand with a simple diagram and also with one existing comparison with the AMQP protocol. Okay, so let me simply write it now. I'm especially explaining the difficulties without the event streaming in microservices. That is one part. For example, as you have seen here, as you have seen in this diagram, so this is the category service, isn't it? So let me take it. So this is the category service. This is the category service. Now, this category service is providing the list of categories in which a product can be created. For example, this is the backend application. If you can see in backend applications, for example, Amazon, Flipkart, if you can see the back office application. Whatever we are seeing is the front application as well. Now that back office application is doing what? That back office application is creating the products by choosing in which product, in which the product which goes to in which category. So the product it is creating, and while creating it will choose in which category it is. Assume the product is, it is like this. The product is the for example just a Sony TV, just assume, and category of it might be the electronics appliances. Right, now if you can understand clearly, there is a Sony TV appliance product, and this product is added with a category called the electronics appliances. Later in time, what happened, the category has been updated to electronics. Initially, it was given as electronics appliances. Later on, it was updated as electronics. Then when the electronics is updated here with the category, product service also should have to notify, isn't it? Product service should also notify by saying, hey, product service, there is a change in the category. Please, you also can change it. Right? So then some event should have to be triggered back to this product service. Some signal should have to be triggered back to this product service. Right? So this is the signaling, simple signaling. Now, when a signal will be triggered back to this product service, then product service will connect to that signaling mechanism and then get the changes. For example, that signaling mechanism is the queue. So what we can do, we can take a simple queue. So this is the simple queue. What will happen in the communication? So it will push the changes, meaning whatever the updates the category have, that it will push the updates to this queue. Let me keep it somewhere here. It will push to like the queue. And the product will listens to this queue, keep on, and then get the data from this queue. So probably let me write it something like this. Yes. So what it will do, category will be update into the queue category status. And then from the queue, product service is continuously listening. Let us say this queue is created using the RabbitMQ. This is clear, pretty clear, right? So without any questions, without any issues. So there is a category service, there is a product service. Product service is taking the changes when the category updates, right? Product also need to be notified. That is the code what you are exactly seeing here. So we have used AMQP category service queue, to which the product is connected to, and then getting the data, right? And then preparing the object mapper, and then of course reading the data basically from the queue. So it is connecting to this queue, meaning this is where product service. So product service is connecting to queue and then getting the data from the queue. And finally doing one, what is actually with this data queue, it is doing some other operations, that is different story, but getting the data on some signaling mechanism. This is clear. Now what is the, why we need to go for the, yeah, so if it is an asynchronous communication, this is asynchronous communication. In asynchronous communication, we should not use the REST templates, isn't it? REST templates, Fiend clients are used to establish the synchronous communication. But this is asynchronous communication. Asynchronous meaning category service when updated, it will push its updated status to the RabbitMQ and then forget it. Fire and forget. Then product service will do what? It will receive it and then gives the acknowledgement back to it. Once the acknowledgement back, then it will take by the category service. Mean the time it will takes the other category changes and all. Right? So that's the difference why we need to go for it. Okay. Now this is clear, pretty clear. Category service updates are coming to this product service. This is clear. Assume we need one more service also. We have one more service also. Let me take that one more service is where category updates are required to that service also. Assume order service. So directly order also we can place based on the categories that we were chosen. Meaning I want to place the items which are under the category of the appliances, or which are under the category of the clothes. So that also I would like to, meaning I can also take the updates from the category service, because based on category I will update the order service, meaning some discounts needs to be updated. So and so order for so and so appliances of the category, some discounts I need to apply. Assume just a general use case I'm talking about. So now what will happen if that is the situation? Then what will happen? Order service also need to consume the updates of the category, right? Updates in the category also need to be taken by this order service. But what happened, there is a problem in this communication. What is the problem in this communication? In this communication, as we are using the AMQP protocol, so once the message is received by one service, so here we can say what this is updating the category changes to the queue, right? So this we can call it as a producer, isn't it? And these are all taking the updates from the queues, right? These we call it as a consumers, right? So these are all act as a consumers. Now these consumers will connect to a queue, and then through the queue, these consumers will get the data from the producer. Now in this architecture, exactly what you are now looking, order service won't get the updates from the category service, though category service pushed the updates to this queue. Why? Because we are using a MQP protocol here. As per that MQP protocol, once any message will be received by the any of the consumer, that message never be available to other consumers. That's the problem with the AMQP protocols. Got it right? Once the message will be consumed by the any of the consumer, that message will be taken out from this queue, so that if any other will connect to this one, he won't get that one. So this design is helpful in the case of the use, in the case of the situation, customer driver cab booking. If there is a situation like customer driver cab booking, this scenario will be helpful, right? Customer driver cab booking, this scenario will be helpful. Why? When the customer is booking a cab, the request will go to a queue where all the cab, of course, drivers will have the application with them, right? Driver application. So all the driver applications will connect to the queue, and who will accept the ride, for them only the ride will be allocated. For the rest of the drivers, their ride can't be allocated. Ride is not allocated. Right? That in that situations, this is helpful. But what I'm saying is, if one or more consumers want to retrieve the data from a queue, our traditional MQP protocol doesn't suffice. So then where we have to go? We have to go for the another protocols like Kafka. So what the Kafka will do and how this problem will be resolved with the Kafka. I think you got the problem, right? Once the product service receives the category updates, those category updates will be removed from the this queue, and then the order service don't get those updates because it is already taken by the product service. Assume in some other cases, if the order service will get the changes from the queue, then product won't get the updates, because if any one of this consumer gets the data from the queue, it will be taken out. So there is no message storage mechanism here. Okay, this is one situation. And second situation is what, there is, assume some interview is happening. Nowadays, everything will be online, isn't it? Nowadays, everything is in online. So assume the case, there is a kiosk like your ATM machine. So there is a kiosk like ATM machine. So let me take that kiosk. So this is the kiosk. This is the kiosk. Kiosk meaning like your ATM machine. So this is the kiosk, like your ATM machine. Assume the situation. I think you might have attended various interviews, right? Face-to-face interviews, Zoom interviews, like that they are happening. But sometimes what will, they will install one kiosk. This is not for our job interviews. In the case of airports, in the case of military bases, what they will do is they will install one kiosk. So we have to do what? We have to go to this kiosk, show our passport. It will scan, the kiosk will scan our passport, and then start asking the questions to us. And we have to answer the questions. Maybe the options we have to choose here, right? It will ask us to, do you go to, did you seen that in the ATM screen, right? How much money you want? You want in tens, hundreds or 500s or 200s, right? Do you want to show the bank balance? Like that, it will talk to us. That is how it is automated teller machine. Similarly, there will be kiosks at sea at the security border forces and some airports. What it will show? It will show us the some questions. It will first, whenever we go to there, it will ask us to enter your passport number. Once we enter your passport number or scan here. So once we scan it, it will read the passport number and scan the details, then start asking the questions to us. Of course, the questions will display on the screen where we need to answer those questions. So what will happen? Those questions will be continuously streamed back to data center. Data center meaning the databases. So here is the data center. So to this data center, the questions needs to be continuously streamed to this data center. Of course, from this data center, we can partition the data, and then we can also keep the databases. By partitioning the data center data, we can take the data into the databases. Meaning from this data centers, I will connect, our database will be keep on dumping with the data that is receiving to the data centers. And this data we can show in the application. For example, I'm just trying to opening one application. The application image I'm trying to open. Fine. So this is the application. So two cases are now happening. Sir, why we need to go to data center directly? Can't we put the data in the databases? That is different discussion. I'll explain. But for now, you understood. Whatever the questions now the interviewer is giving, that questions will be streamed to this data center. From the data center, the data will be continuously from the data center, the data need to be continuously pushed to our databases. So these databases are in replication. And from the databases, our application will pull the data and then showcase that data in our application. Now, in this entire flow, what are the challenges, sir? Seems to be very fair. No, the challenge is there may be many number of persons will come and then attend the interview. Each and every person record we need to maintain here. So how do we maintain that? Okay, sir, I will open the queue. Just let me take one queue. Sir, I will open the queue. For one interview, I will open the queue. For example, user 1 is attending. With his passport ID, I will open one queue. In order to recognize the queue name uniquely, I will create a queue with the unique passport ID, passport number, and then dump the data here. Once that the interview is done, then we will delete this queue. Good idea. The solution is somehow good. Each and every interview, one queue will be created, takes the data, put the data into this data center, and then further streaming will be happened here. This is good. 1,000 interviews will be happened per day. 1,000 queues will be created. 1,000 queues will be deleted. But of course, data will be reached to this data center. Right? Parallelly, data will be reached to data center. Parallelly meaning what? For example, through this kiosk, 10 interviews were conducted. Assume. So 10 queues will be open like this. And these queues will be on or off. Right? Once the work is done, delete actually. Fine, this is good. But again, we have one challenge here. What is the challenge is? order. So when the user is attending the interview, right? Interview question, show me your passport. Yes, passport we scanned. Then ask one question, are you taking any narcotics? No. Are you traveling to, for example, passport it scanned, right? Maybe visa also it might scan. It will ask just double verification. Are you scanning to US? Yes. Which state of the below you were traveling to? For example, California. And how much time you will travel? How many times you will travel to California? Like that, some general questions it will ask us to validate. Are we really going there? Are we the real person going there? It just validate it. But whatever the validation is, the questions it is asking in an order, right? Just by scanning the passport, scanning the visa ticket, or maybe the passport, it will scan and then showcase the visa ticket and all. At least what it does is, it is asking the questions in some order. And the questions in that order only we have to put into the data center. So current AMQP protocols are not following any order. There is no ordering. There is no ordering of the data in the current AMQP protocols like RabbitMQ, isn't it? So when the order is matter, when the order is preserved, our RabbitMQ doesn't help us. Meaning our AMQP protocol doesn't help us. And who will solve these problems? Two problems we have seen now. Number one problem we have seen is data storage in the queue, right? If we take the MQP protocol, data will not be stored here. Once any consumer will receive the data, other consumer don't have the data to receive. So data storage in the queue is one problem. Next, data ordering in the queue is one more problem. So these are the two simple problems. There were many other problems as well. So the problems such as data storage, data ordering, these will be resolved using the Apache Kafka. And also continuously, if you would like to stream the data, yes, what is happening here? Questions are asking and then streaming to these queues and then putting into the data storages, data centers. This is somehow continuous only, but the problem is ordering is missing. Any questions? Yeah, can you please mute? Yes, somehow the ordering is missing here, right? So these are the two problems. Of course, there were many problems also. These will be solved using the Kafka. So how Kafka will resolve this issue? So in place of the same diagram I will take, but here I will take that same diagram. So here is the category service, and here is the one consumer called the product service, and here is the order service. Now what we will do is, let us create the topic. Let us have Kafka in place. So in Kafka, we call them as the topics basically. In Kafka, we call them as the topics. So let us take one topic. So this is the topic. So subscriber can subscribe to it, producer can produce to it, and then the subscriber can subscribe to it. I'll do one thing, just let me take it off and then keep it like this. This is the topic. So now what will happen? The category service will update the data to this topic, and the other services will connect to this topic and then consumes the data. So Kafka resolves now the problem of the data storage. By default, the Kafka will store the data in each and every topic for 7 days. So if we want, we can also uh, increase it or maybe decrease it. So that is possible. We can customize it. But now what is happening? So category service is putting the data to this topic. This is the topic. This topic have the uh, this topic have the mechanism of storing the data in this topic for 7 days. Of course, we can also increase the time and decrease the time. So the data once received by the product service, still the data will be there. And that data again will be taken by the order service as well. So likewise, one topic can be shared by the many microservices, or one topic can be given to one microservices, but the data storage is here. So one problem is solved with the Kafka. Next problem is data ordering in the queue. So in this example, what we have taken Kiosk, right? So data ordering. So Kiosk is here. And then we have taken the interviews. So these are the interviewees who are attending for the interviews from this Kiosk. Now these interviews are putting into the topics. Now a number of topics are like this. Now topics will do what? Topics will ordering the data. So every topic will have a concept called partition. Every topic will have a concept called partition. So we will partition it. So every topic will have a partition. So this is n or more partitions, one or more partitions we can do. So this is one partition and this is other partition. Now what will happen, one or more partitions we can do. These partitions again have the indexes. So whatever the data, the interview questions are floating for one interviewee, right? For one person, one topic. Inside one topic, there were 10 questions. Each and every question will go for one partition. Each and every question will go for one partition. Now the partition will have the indexes. Assume this is the partition. Now partition will have the indexes. So the indexes like this. Probably I can take indexes. So every partition will have the indexes like this. So I can say this is I can refer. So assume this is one partition and every partition will have the indexes. Index 0, index 1, index 2, index 3, like that. So first question will be pushed to index 0. Next question will be pushed to index 1. Like that, 10 questions will be pushed to 10 indexes. Right? So 10 questions will be pushed to 10 indexes. Now, once the 10 questions will be pushed to 10 indexes, the order is now preserving, isn't it? So at the other end, what will happen? The other applications. At the other end, we said data center, right? So data center can have the, of course, data center meaning some application or some program running at the data center will connect to these topics and then get the questions and then put the questions in the same order into the DB, or the database that we were written is connecting to these topics and then storing in the ordering way. Okay, that we can decide at the consumer side. Right? Now the problem of the ordering is resolved, isn't it? So now the problem of the ordering is resolved. So what is happening here? Every data, every interview question is putting into this partition. Every partition will have a indexes. We called it as a record. Nothing, every partition, nothing but every topic, nothing but one table we can consider. Like how the table will have the columns, right, for the data storage, right? So a table will have the rows, number of rows, where each and every row is nothing but one partition you can consider. and each and every row will have the number of columns that you can consider as the indexes, right? So likewise, the data storage problem resolved and data ordering problem also resolved, right? This is very beautiful things. And as the data, now there is one more thing we will see. Did you heard about the MQTT protocol? Of course, MQTT protocol in the sense device to device communications. So device to device communications. For example, your let me try to show one MQTT protocol view, just a simple diagrams. It's how the MQTT will be there. This is the MQTT, right? What is happening? Appliance to appliance, device to device, appliance to appliance, right? In the case of MQTT, right? So let us see one use case with the help of this MQTT. There is AMQP protocol we have seen. Now let us see the MQTT protocol. So how the MQTT protocol, I mean, the Kafka resolves the issues in this one. Okay, so now let us see one more use case, like what Kafka will resolve. You got it, right? Are you getting me? So why the Kafka is used and where we will use it? So always what we will write in our microservices case, we will write one producer, we will write one consumer, and this producer and consumer will connect to this Kafka topic. And how to connect and all we will see. From the very scratch to the advanced level, I'll explain this Kafka. From the very scratch to the advanced level, like security, handshake, SSL level, I will explain. Okay. Now. So yeah, now we understood the record is meaning the data is storing into the topics in an order. Yes. Now we understood how the Kafka resolves the problem. So let us see now what is Kafka. So Kafka is resolving these many problems, right? What is Kafka actually? Right? What does it basically? What is Kafka? So let us go and then see the Apache Kafka. You might have also seen Confluence Kafka, right? So let's see the Apache Kafka. What is this Apache Kafka? If you see the Wikipedia, Apache Kafka is a distributed event store, observe event store, and streaming processing platform. Very, very important. Actually, if you can see in the big data, Hadoop, right, Spark, Scala, those are frequently using this Apache Kafka, like for streaming the media, video informations and all. You can't believe nowadays, till now also, in Java, we don't have proper streaming platforms. Right now, Java 13, Java 15, Java 17 also came, but we don't have a proper video streaming platform in Java. So proper video streaming platform in the sense, what does it mean, sir? What does it mean is, assume you are answering the questions. Power gone. Once the power gone, assume what this machine need to do once the power gone and then power came. This machine again asks you to show me your passport, and this machine will start the questions from the beginning. No, that is not good thing, right? It will resume it once this is the device. Once the power gone, right? If the storage is not there, what this device will do? This device will again start the interview from the beginning. It will ask, hey, show me your passport, and answer these questions, like that it will ask. Correct? Because if there will be no storage. But now with this Kafka, we have the topics here. We know topic will store the messages for minimum 7 days as by default. Now what will happen when the power will gone and then power will come? It will immediately go and then get the data from the topic. Immediately Go and get the data from the topic, and it will start showing those questions. Of course, whatever it will go to this topic, what is current index, it will find out that current index question, it will resume here, isn't it? Now see how easy it is for the user experience, right? So interview will be continuous even without interruptions. So what happened now? The event store or data store mechanism of Kafka making our transaction smoother, even though the interruptions, obstructions occurred like hardware failures, power failures. That's the beauty, and that's how the Kafka is using in many cases, right? Correct. So this is the producer, and here is the consumer. So we have also a concept called resilience, fallback, fallback, fallbacking data, fallbacking. We also have a concept called fallbacking in Kafka. Using that fallbacking, this will retrieve the data back. Okay, of course, we will see those things. Yeah, fine. Now, this is the problem like Kafka is solving. Now, what is this Kafka? Kafka is a distributed event store and streaming processing platform according to the Wikipedia. And let us go to Kafka documentation, and then let's see the Kafka concepts getting started. So Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance of data pipelines, streaming analytics, data integrations, and mission critical applications. Every industry, manufacturing industry, banks, insurance industry, telecom industry, every industry is using this Kafka. See a full list, and see manufacturing 10 out of 10 companies. If we take 10 companies, 10 out of 10 required to use this Kafka. Banking industry, 7 out of 10 banks are using, because payment failures, transactions, and all need to be resilient failover, meaning there should be a fair enough storing mechanism at each and every step, and then there should be a tracking mechanism, right? So that is happening with this one. See, so lots of these are the many members who are using this Kafka, right? Datadog and what we know, a lot of things were there, but what we worked, I'm just look. Datadog is what I know. Maybe you also know many things. Yeah, LinkedIn is the mother of this Kafka, right? Because the LinkedIn concept or LinkedIn is implemented this Kafka basically. Of course, that is different story. I'll come to that story. But if you can see this, these are all the many. Netflix is using Kafka, Mozilla is using Oracle, and then so Oracle Fusion middleware. Lot of Gaint are using, lot of Gaints companies are using this Kafka. Spotify, the music thing, right? Shopify is more client, I mean, application, so which will produce the retail e-commerce solution to the clients and customers. Okay, so Twitter is also using, not whatnot. Lot of the members are using Kafka, right? So definitely we also need to use Kafka in our applications somewhere where we will use microservices, right? Definitely we will get a situation to use Apache Kafka also in our projects. RabbitMQ, we have seen the problem with the RabbitMQ, we have seen, right? The the problem with the RabbitMQ is what? It is not maintaining the message ordering. It is not maintaining the message storaging, right? It is not distributed, because the message once received by the one consumer, the other consumers can't take the messages from this RabbitMQ queue, right? So, but it is distributed. Kafka is distributed. Yeah, AMQP is a protocol. Under AMQP, we have the RabbitMQ, ActiveMQ. These are all the AMQP protocols, right? So what is partition? What is record? What is topic? What is partition? And what is record? We will discuss this in a moment of time. But first, let us see the what is Kafka and what is continuous streaming. So we have not completed the continuous streaming part, right? Just we have seen two problems, and then we have seen how the Kafka is providing the solution for those two problems, isn't it? So, but what is this Kafka actually? So Apache Kafka is an distributed streaming platform, distributed event store streaming platform as per their official documentation, right? What does it mean? We need to understand its meaning. What does it mean? It means number one, we can use the Apache Kafka. We can use the Apache Kafka to create the one or more data streams, in real time. Here, real time meaning don't assume it your work or something. No, you are using your Ola application, Uber application, right? You have book a ride. Then your ride has been, meaning you driver accepted your ride. From the moment driver accepted your ride, you can see the driver where he is coming. That is real time. Every minute, every second, every hour, every millisecond, the data needs to be updated to consumer, right? The data needs to be updated to consumer every moment, every minute, every hour, every millisecond as well. That is what the meaning of real time. Okay, so we can use Apache Kafka to create the data streams. Now what it will do, this Apache Kafka will create these data streams. For example, these topics it will create the data into these topics, right? It will create the data streams in real time, meaning every minute, every second, it will keep on dump the data to these topics, right? Whereas the other side, consumer side, right? We can use the Apache Kafka consumer side. We can use Apache Kafka process this real-time stream of data, right? Real-time stream of data, and produces the reports of the real-time data if required. Right? Did you went to DMART anytime? Number of times we went to DMART, right? In DMART, what will happen? In DMART, there were again lot of kiosks like this, the same use case. In DMART, lot of kiosks we have like this, right? POS machines, point of sale machines, we would say. POS, point of sale machines. Let me take this point of sale diagram. So in DMART, we have this point of sale. Exactly, this is the point of sale machines you can see. So these point of sale machines will do what? These point of sale machines will do a billings for every minute, for every second, throughout the DMART, overall the India or overall the world. Definitely their frequency of billing is at least every minute, right? So for example, here are the users. Now each and every user, let us say this is one person. So here is one user, and here is one user, and here is one user doing the billing. I mean to say paying the billing and all. And here is one person who is paying the billing. Now what is happening? This kiosk will takes the data, right? And then generate the unique transaction ID. And then this will be dumped to the one topic, right? And then this will be dumped to another topic. and this will be dumped to another topic. Transaction specific topic we can create, or else one topic is good enough to handle all these transactions. But in ideal way, let us create many topics, at least one topic for each and every transaction. So here, these transactions, each and every transaction will be created with one topic. And there will be a data center. Again, large data will be stored in the data center, right? So here is the data center. So this data center will do what? Data center will continuously receives the data. So continuously, this data center will continuously receive the data from these topics. So let me write it like something like this, continuously. So it will continuously takes the data. So continuously take the data, continuously, for every minute, every moment, every hour, it will takes the data. Right. So this is one industry where we are using the Apache Kafka. Not only this one industry, in banking industry, and then in the traveling, or you can say hospitalities, and then the retail, banking, even manufacturing industries. Lot of industries we are using the Apache Kafka. Now, if you can see, creating the data stream into this topic, creating the data stream into this topic, correct? This it can do. And then what? Once the data is created here, it will be continuously streamed to this consumer. Continuously stream it to this continuously stream it to this consumer, right? So now inserting the data from this POS machine, inserting the data from this POS machine to this topic is called as creating real-time stream. Inserting the data from this POS stream to this topic is called what? Creating real-time stream, right? This is creating the real-time streaming data. And here the consumer is do what? Consumer will process the real-time data. He will immediately connect to this topic, listens to this topic, and then stream the data. So this is called what? Streaming the data. This is creating the data, creating the streaming data, and this is the processing the streaming data in a real time. Real time meaning every minute, every second, every minute, every second, we will process the data, right? So in our day-to-day life, especially we are using microservices. In our day-to-day life, we will see this situation. So in our throughout the course, let us take one implementation, POS implementation. What is this POS implementation is? Let us create one QR code. So in our throughout this Kafka course, so let us take one use case, that is QR code scanning. What happened? Marketing. So let me take some QR code. Okay, so let me take some scan. Scanner. Yes. So what we'll do is, let us take one example called QR code. So let us take one QR code. So what we will implement, I'm telling you. So let us take one QR code. So the use case, what we will implement, I'm just explaining to you. So that use case we will implement using the Kafka. So this is our QR code, right? So this is the QR code. So likewise, we have the many QR codes where each and every QR code will contains some data. For example, one video, some text data, right? Some other data it will contains. So when QR code will be scanned by this scanner, here scanner meaning you assume it as a one Spring Boot application. Of course, QR code scanner, of course, scanner we will use. This scanned data, what we will do is, let us send this scanned data to our Spring Boot application. So here is the Spring Boot application. So what this Spring Boot application is doing, it will taking the data from this scanner. It will take the data from this scanner. So this is our Spring Boot. It will take the data from the scanner. From the scanner meaning, assume the scanner is there. So we will send the data to one of the endpoint of it. Now the Spring Boot will do what? Spring Boot will connect to the Kafka. Of course, Kafka meaning, I mean to say Kafka topic. So it will use the Kafka and then put the data into the Kafka. Of course, Kafka topics you can understand. So Kafka topics. So it will put into this Kafka topic. Now what this Kafka topic have is the video and then other information, right? Video, other information. Like assume the case, you are booking the tickets, right? Now still there is a manual process. When you go to the theater, there is one person who is verifying your tickets, right? And sometimes what will happen, they don't see, even there is a huge crowd, they don't, it is manually, it is impossible to verify everyone's ticket. Assume if that is the situation, when you are allowing into the theater, there will be a scanner. So where you have to show your QR code and then that will validate your ticket. Once the QR code is scanned, it will immediately show you the trailer of that movie. Just assume the case, right? Once your QR code is scanned, the trailer of the movie will start playing in your mobile. Two things are happening here. Your ticket is validating and the trailer is coming to you, right? So assume that is the situation. Now this when the QR code will be scanned, then what this will do is this Spring Boot application will put the message into the Kafka, and then other side we will write one more Spring Boot application. Other side we'll write one more Spring Boot application, which will continuously two things it will do. Not only producer consumer, we also will do the streaming. You have to understand that very carefully. We also will see the streaming both. So there are 4 APIs in the Kafka: producer, consumer API, connect API, streaming API. So we will discuss producer consumer API, streaming API, connect API, of course, not part of it, but streaming API we will discuss. So what it will do, it will consume the data, and this consumed data will be sent to the customer, email address. Like, your ticket is valid. And here is your, of course, message. Some message also we can see, like, OTP kind. OTP not coming, but let me take message. Some message. So every customer who have been scanned with their QR code, ticket, you mean to say ticket. So that customers need to get the confirmation of their ticket information along with the trailer video. These customers need to get the email confirmation and of course message we are not going to implement. Email communication we will implement. That email communication will have the confirmation along with the trailer video. So this is the use case that we will see. And in this use case, you don't think in a way like, sir, this is simple publisher, simple consumer. No, of course it is pubs and subs model only we'll discuss, but lot more here. Meaning what? This QR codes can be many real time, right? How much time it will do? Very fast, actually. It should be very fast. Once it is showing to Kiosk, in a moment of time, it needs to be scanned and then verify your ticket. The next person will come. Continuously, at least for every 10 seconds of time, the data will reach us to our producer. The data will reach us to our consumer, and then data needs to be acknowledgement back to the customer. Right? If the scanning will take 1 hour, then when he will go to movie, when he will see the movie, isn't it? So faster performance is required here. right? Yes, yes, we're going to implement this complete use case in weekend. Correct, correct. It is easy, don't worry. Very easy, we can use. QR code generation logic, QR code generators are already there. So here we will just write a logic to QR code decoder, of course. One endpoint we'll implement here, which will take this QR code data. Okay, so this is the use case that we're gonna implement, right? So that's all for the demo point of view about the Apache Kafka. And actually, today I have the client meeting, so I need to work on some office work I have. So whoever be interested, you go and then proceed with your registrations. So let us start this Kafka implementations. Yeah, let us start this Kafka implementation, entire use case discussion, Kafka topics and all. Let us discuss tomorrow and also coming Saturday. So I thought to take it up in one weekend, but today I have some work. So if you feel if it is okay for you, if it goes to tomorrow, we will discuss the concept and then one part of implementation we will do. And after tomorrow, meaning in the coming next weekend, next Saturday, we'll complete this entire process. So by that way, you will get the material and then you will get some time to understand the concepts and then practice yourself and then come back. Okay. So if you feel okay, then so fee is 1,500 actually. So you talk to Bhajan team and then get your registrations done if anyone is interested.
Videos will be recorded. Videos will be given, sir.
Yes, yes. Recordings will be given and recordings will be valid for 1 month. 1 month.
Okay.
Yeah. So tomorrow is, yes, tomorrow we have the class. So today you go and then do the registrations. Tomorrow let us start the class. Tomorrow 9 a.m. 9 a.m. let us start the class. Tomorrow 9 a.m. let us start the class. Okay, 9 a.m. to 2 p.m. 9 a.m. to 1:30, 2 p.m. Let us discuss and let us wind up, because slowly we will understand too much of concept injection is also not good. So next Saturday, no need to pay. Once you for joining on next Saturday, we need to pay fees, right? Correct. For joining on next Saturday, we need to pay. Tomorrow, no demo. I'm done with the demo. And tomorrow, let us start its implementation. Go and complete your registrations today. Tomorrow at 9 a.m. we'll connect back and then complete this. Start this Kafka course, and then yes, materials and all I will provide tomorrow. Once you done your payment, I will provide the material tomorrow itself only. All the material I'll provide tomorrow itself. So tomorrow we'll complete all the Kafka concepts, installation, multi-node broker, multi-node architecture installation with the zookeeper, and then many brokers, at least 3 brokers, 2 brokers will take. So we'll done tomorrow the installation, Kafka concepts discussion, Kafka installation, and then Kafka producer consumer implementation we will target for tomorrow. And next weekend, let us target for the streaming of the video with this complete use case. Okay. Yeah. Yes.
So what?
Yeah.
Hello, am I audible?
Go ahead, please.
Actually, I've registered for your Spring Boot batch that is being run on 8:30 for 3 months. So this is a new course. Which should I book for, or this part is also being covered in that one? So just
Yes, this part also will be covered there. So, but as not part of the weekend, for you it will take 7 to 10 days to complete the concepts. But for this is what weekend, just Saturday and
So
then Sunday.
for me, this is specifically individually not required because this will be covered there, right, sir?
This will be covered there. Yes. Till that time, if you have any urgency in your projects or would like to do some POCs, you can attend here as well. But no need. Who are the members enrolled there for them also there it will be covered.
Okay, sir. Thank you so much.
How much fees?
Sorry, what is the question?
How much fees?
Fees is 1,500. 1,500. Material will be given, and then the videos will be provided. The validity of the videos will be 1 month. And examples, I will provide the Git repository and all. And yes, I will explain very in-depth of the Kafka from very beginning to in-depth concepts we will see, because SSL is there. Security.
How many days will it take, sir?
Actually, this is planned for 1 weekend, but as today I have some office work and all, so I'm not taking any class. Tomorrow we will start Apache Kafka. So the concept is what, I will write down, you will get an idea. So tomorrow what we will do is, let us complete Kafka. Let us complete tomorrow the Kafka core concepts. Kafka core concepts and Kafka architecture. Kafka architecture.
We need hands-on experience, sir. Actually,
That's
we
all.
are using in our project.
See this use case, when I said this use case, this definitely we have to implement hands-on, right? So we will implement one producer, we will implement one consumer, isn't it? Hands-on only we will do. It's not kind of, already existing code I'm not showing. Okay, let us implement from very scratch. We will implement.
So tomorrow, how much time will you take, sir?
That's what I'm now typing here. So tomorrow, let us take from 9 a.m. to 2 p.m. At least 1 p.m. is guaranteed. That one again, till to 2 p.m. Let us see based on your ingestion and all. We will see.
But tomorrow
So
it is complete, sir.
no, tomorrow it won't be completed. Tomorrow it won't be completed. Let us also take it in the next Saturday.
Sir, can we start tomorrow at 10 a.m.? Is it possible?
Yeah, that's okay. 10 a.m. is fine. If you are 10 a.m. to 2 p.m. let us do that.
Yeah, it will work.
This is required. Yeah.
Thank you.
So Kafka core concepts, Kafka architecture, Kafka installation. This installation we will see on Linux. Linux we will see, and then on the Windows we will see this installation. And again, this installation of type. Single node architecture and then multi-node architecture. So there is an in-depth concepts you will see here. And after Kafka installation is done, we will see the producer API, and integrate this producer API with our Spring. Then we will see the consumer API and integrate the consumer API. Then we will see the end-to-end flow. And of course, once this is done, next weekend, what we will do is, let us work on the streaming API next weekend. So next weekend, streaming API and then security. So this will be completed in the next Saturday. So tomorrow and then next Saturday. By next Saturday, streaming and then security will be completed.
Sir,
and tomorrow,
yeah, what is the link to register? Where is the link?
actually, can you speak to our backend team? There is a number actually, backend number. Just talk to them actually. In our DURGASOFT website, we have it. Let me go and then check the link to do the registration. Let me go to DURGASOFT.
Hello, sir.
Yes.
I'm audible. Are you going to cover Avro as well?
Avro, not covering actually. I'm not covering Avro. Of course, POS machines and all we do, but I'm not going to cover that because I have my own use case. So this use case.
Theoretical wise, no, sir. We need how to write the publishers, how to get the consumers consuming through existing procedures.
Correct. So what I think, do you guys got the use case what I explained? In this use case, what we will do, I hope you got it right. So here we will write one Spring Boot application with the Kafka integration. That's what I'm writing here. Producer and consumer we will write tomorrow. Streaming we will write in the next weekend. Everything is practical only, installation and then programming, coding. There are two parts of it: installation and integration.
This is a both.
We need record session also, sir.
Yes. Recordings will be provided. Yes. Session is recording and recordings will also
So
be provided.
producer and consumer applications, are you teaching entirely in the Spring Boot, or how is it?
Spring Boot. Entirely I'm teaching in the Spring, explaining in the Spring Boot.
And the Spring cloud streaming as well include, sir?
No, cloud streaming I will not include, but based on the time constraint and all, of course, let us see in the next weekend. However, we will start the streaming, right? Streaming API. So at that moment, if the time will permit, let us see.
Okay.
Yeah.
This Kafka,
Any more?
conference Kafka or this Apache Kafka?
Yeah.
Both?
So this is Apache only. Confluent is the paid version of this Apache Kafka.
But we can work with this concept, right?
Concept everywhere. Concept is same. Everywhere concept is same. But that is managed one. So Kafka is available in 3 flavors. One is open source. Second one is the commercial, and the third one is the cloud. So these 3 flavors it is available. Open source is Apache Kafka under the license of MIT, and then commercial is Confluent Kafka, and then similarly we also have the cloud Azure Kafka we have, and then AWS also have the Kafka support. So like that we have the cloud. So we will see only this Apache Kafka raw, meaning
But
very
concept
scratch.
similar, no?
Concept is underlying. Concept is Kafka only. The concept is same, but they are managing with the commercial, like if any issues will come in production.
Any internal architectural changes? No, right?
No, the changes, no changes, but the problem, they are simplifying it. If it is an open source, if any issues will come, no one is there to help you. If it is a commercial, then they will take the responsibility of help you. If any issues will come, you can raise the ticket. They will have a help desk. They'll come back. Their engineers will join with you and then help you in the complex integrations. If any such help is required. In the commercial, mostly products will be commercialized mostly because of the support only. Got my point, right? Yeah. Okay, guys. So if it is
See the
Last
payment
question from my side. So, is there any programming knowledge is required, or you will explain the program?
Programming knowledge is, however, required actually, because this is I'm going to use here the Spring Boot, right? So little bit programming knowledge is required. Of course, Spring Boot is definitely have to know. The expectation is prerequisite is you guys have to know the Java programming language. That is the expectation.
Okay, thank you.
Yep. Okay. Yeah.
Tell me the payment. Where can I get it, the payment link?
Yeah. Just now you got one message in the chat. Can you go through that chart? Actually, there we have the payment information.
Okay.
Yeah. Okay.
Sir, when will the next Spring Boot batch start?
Next Spring Boot batch, already Spring Boot is started.
Yeah, but it is at 8:30 AM. That is the issue.
Okay. Timings issue, na?
Yeah. If office started, then I need to go office. That is.
Okay. Actually, it will take little time. My next Spring Boot batch will take little time.
This Kafka only for 1500, right?
Yes, Kafka is for the 1500. Yes, correct. Kafka material plus videos plus GitHub link, whatever the examples, whatever the use cases will implement, the GitHub, all will be provided. Video will be validated for 1 month. Okay. Yeah.
Sir,
okay.
Please provide the link to the mail, sir. We provided mails, right, for registering.
Okay. Sure. Meaning, what is the link you are asking about? Registration link or what it is?
A payment link, sir.
Payment
Without
link.
payment, tomorrow you won't allow us. Correct. Already we learned Spring Boot sessions.
Okay, great. Then it is easier for you. See, actually, in the chart, if you can go to the chart, there is a message with all the details of the payment and all. However, I am also pinging it one more time. Can you please copy and then paste it with you? So just, yes. So please do your registrations and then come to tomorrow class. Tomorrow, let us start the classes at 9 AM. Okay. So tomorrow we are starting our Apache Kafka course. So today is the demo. If you feel it is okay for you, you go and then do your registrations and then come back with the registration details.
We need all the materials, sir. Otherwise, we can't. Once we'll pay the money, then afterwards you won't pay. You won't give means it is difficult for us. We need, sir.
Correct. Material will be given actually. Meaning Kafka material I will give. All the material in the sense Kafka material
and
I will
recording
give.
Also, because once again, see, at a time listening means we are not that much listeners.
Correct.
We'll go
Understood.
to 3D time listening and we can understand.
Sir, tomorrow at 10 AM or 9 AM?
Sorry, 10 AM. Let's connect at 10 AM. Okay. Tomorrow 10 AM. Okay, 10 AM to 2 PM.
Sir,
Okay.
if time is there, can you go through Avro as well? It is very important in Kafka streams.
Sure. I'll definitely.
Yeah.
So, but let us take it in the next weekend, because tomorrow,
Sure.
first of all, concepts injection is very important, right? So tomorrow, I think
Correct.
we will spend a lot of time here. Next weekend, I
Yes.
will definitely cover this. One is the Spring Cloud stream. Second one is this Avro. I'll cover it.
Yep. Thank you, sir.
Okay. Thank you so much, folks. Any question? Any questions? Yeah. Okay. If nothing, then I'm stopping my screen share. Thank you so much. Thank you. See you tomorrow at 10 a.m.